Okay, today I'm going to talk to you about current and circuits. To help illustrate this, I've just got a real simple circuit here that's made of a cell. That's what provides the push or potential difference in the circuit. An ammeter, that's what measures the current, a filament lamp, and a switch. So, whenever we think of current, the first thing we think of is a flow of charge. Just like, for example, in a river, the current would be the flow of water. In a circuit, it's the flow of charge. And in particular, in a circuit with metal wire, the thing that is flowing around the circuit is electrons, or rather are electrons. So to understand more about this, we need to know a little bit more about the structure of a wire. So wires normally have a plastic coating because plastic is an insulator and doesn't allow the electricity to flow out. Inside that plastic coating, we have a metal, often copper. Now that metal is what contains the electrons which flow around the circuit. Underneath, I've done a diagram to show metallic bonding. In metallic bonding, we have lots of positive metal ions, and all around the ions, we have these little delocalized electrons. What that means is, when the circuit is provided with a potential difference, a kind of push, these electrons are free to flow around the circuit. They flow around the circuit. Now, the mistake that lots of people normally make is they think all the electrons start here in the cell and then they leave the cell and flow around the circuit. That isn't true. Just like we've seen from this diagram of metallic bonding, all of the electrons start within the copper itself. So in this wire, all the way around, there are electrons ready to flow around the circuit. So, why have I put flow of charge rather than flow of electrons? Now, the reason for that is quite simple. Charge is measured in coulombs, and the unit for that is just a capital C. Now, what a coulomb is lots and lots of electrons. So, in order to kind of try and measure the flow of charge around the circuit, we need to be able to count how many electrons are flowing by at any time. Now, the reason why that's extremely difficult is there are so many electrons that will flow around. Electrons are absolutely tiny, and so literally billions of them will flow past the point in, let's say, a second. So that's why instead we use 1 coulomb. 6.28 times 10 to the 18 electrons, that many electrons is 1 coulomb. So that's why we use coulombs rather than electrons. So what is the current? Now, this component here is called an ammeter. This is what measures or counts how much charge is passing a point in a certain period of time. And we actually have this nice equation triangle that I'd like to try to explain to you right now. So Q stands for charge, I stands for current, and T stands for time. So Q is charge measured in coulombs, I is current measured in amps, and finally T is time measured in seconds. So let's just have a quick think about this ammeter here. Let's imagine 1 coulomb of charge, so i.e. that many electrons. Let's imagine 1 coulomb of charge passes through this ammeter or flows through this ammeter in 1 second. So my current is going to equal, to find this out, I do Q divided by T, is Q divided by T. So in this case, let's imagine 1 coulomb passes through that ammeter in 1 second. 1 divided by 1 is 1 amp. So that's what the current is. Current is measuring the flow of charge around the circuit. So if 1 coulomb goes past this point in 1 second, I'm going to have 1 amp. Now let's imagine this time, let's say I've increased my potential difference. So what will happen is this time I've got a bigger push of electrons around the circuit. They're going to flow through at a faster rate. So this time, let's imagine, rather than 1 coulomb passing this point in 1 second, we have 2 coulombs passing through this ammeter in 1 second. So this time, my current is going to equal 2 coulombs passing through in 1 second. So 2 divided by 1 is 2 amps. So can we see the more coulombs that flow through a point per second means a bigger current. So that's basically what current is. Remember, it's the flow of charge. That is what a coulomb is, that many electrons. And what an ammeter does, it reads the current, so it reads how much charge flows past here every single second. Thank you.